Alright, so in this example, we will be looking at a more complicated equation with regards to equation of a straight line. Okay, so let's take a look at example 8. Find the coordinates of the foot of the perpendicular from A 4, 5 to the line x plus 2y minus 4 equals to 0. Now, you realize that in this example, they don't directly give you a point, they don't give you a gradient. Um, it's quite hard to not understand, or it's quite hard to understand the question if you don't draw a diagram. So always remember, when it comes to coordinate geometry, questions with regards to coordinate geometry, it will always help you if you sketch a diagram. So let's take a look at how to sketch a diagram. So we have the line x plus 2y minus 4 equals to 0 here. You realize that if I bring the x over to the right hand side, then we will have a negative gradient. So let's just draw a downward sloping line and label them x plus 2y minus 4 equals to 0. It doesn't have to be accurate. Okay. And then we'll take a look at this point A bracket 4, 5. It can be on either this side or it can be on this side. All right. So let's just select this side. Okay. Doesn't really matter. Okay. Because it's a sketch. It's just to help us understand how to solve the question. All right. Now, foot of the perpendicular, coordinates of the foot of the perpendicular. So what you need is a perpendicular line. Okay. So when they ask you to find the coordinates of the foot of the perpendicular, this is basically referring to this point over here, this particular point. Okay. So how do you go about finding this point? You realize that this is actually the point of intercept between this blue line, this x plus 2y minus 4 equals to 0, and this red line, which is the perpendicular line from A to this blue line. So whenever you have two lines that meet and you need to find the point of intercept, definitely we need to solve the simultaneous equation. But before we solve a simultaneous equation, you realize that I need to find what is this equation of line here. Okay, so what we can do is we can let this coordinates be b so that it's easier for us to present our working. So let's start with that first. Let the coordinates of the foot of the perpendicular be b. Okay, it's just to help us present our answer better. Okay, so with that, to find this equation of AB, again, any equation of straight line, we will always need one point and the gradient. And we already have this point over here. So what we need to find is the gradient, and we know for a fact that the gradient is perpendicular to this blue color line. So if we can find this gradient of this blue line, we can use the fact that m1 times m2 equals to -1 to find the gradient of the red line. So again, because we have this equation in this form, if we can put it in the form y equals to mx plus c, make y the subject, we can easily identify what is the gradient of this blue line. So let's do that first. So we have x plus 2y equals to -4. Make y the subject. So I have 2y equals to -x plus 4. Divide by 2 throughout. I have y equals to -half x plus 2. So now, given that I have the form y equals to mx plus c, okay, we know for a fact that the gradient of the blue line is -2, sorry, -half. So we know for a fact that if I have a perpendicular line, I have the gradient of the two perpendicular line being -1. Or we can use m1 equals to -1 over m2. So what we can do is we can now say gradient of AB is equals to -1 divided by -half. And -1 divided by -half, I will get 2. All right, so now that we have the gradient 2, so gradient equals to 2, all right, we can now easily find out the equation of this line AB. So let's label this as equation of AB. So you realize that it's easier to label your workings once I let the coordinates of the foot of the perpendicular be B. So equation of AB is given by, so we make use of y minus y1 equals to m bracket x minus x1. Again, it will be helpful if you label it as x1, y1 over here. So we have y minus 5 is equals to the gradient, which is 2 bracket x minus x1, which is 4. So simplify this equation. I have y equals to 2x minus 8 plus 5, y equals to 2x minus 3. All right, so this will be my first equation for the simultaneous equation. The second equation will just be this equation over here. So since we already have this equation here, let's just label it equation 2. So sub equation 1 into equation 2. By doing this, we can find this point B, which is the foot of the perpendicular. So we have x plus 2 bracket 2x minus 3 minus 4 equals to 0. Simplify your equation. I have x plus 4x minus 6 minus 4 equals to 0. So simplify this. I have 5x equals to 10 and x equals to 2. Of course, we need the y coordinate as well. So sub x equals to 2 inside my equation number 1. I have y equals to 2 bracket 2 minus 3. So y equals to 1. So now we have it, the coordinates of the foot of perpendicular from A to the line, which is B itself, is given by 2, 1. And I'm done. All right.